This is lesson 4 of chapter 2B of probability and statistics. Our topic today is box plots and outliers. Our essential outcome is you'll be able to create a box plot and find outliers using the formula. Alright, so yesterday in the last lesson we talked about how to make a box and whisker plot. So now what we're going to do is we're going to make a box and whisker plot, but we're also going to have to pay attention for outliers. We did that a little bit when we did the last lesson. So what an outlier is a point that is outside of the range of values found by the following formula. And so it's the quartile 1 minus 1.5 times the IQR range to the quartile 3 plus 1.5 times the IQR range. And so first we got to find some of these values. So here are all of our values right here. So first what we need to do is we need to find the middle of these to find our medians. There we go. We can do this by crossing them out. Alright, we got two values in the middle. The median of those, the average of those would be 21.5. So our first number would be 21.5. That's our median. Alright. Now we look at the lower half of numbers right here. We do the same process. Looks like our Q1 is 19. Now we need to find our Q3, which is 33. Okay. So now what we're doing is we're going to decide if these upper and lower numbers are if they are outliers in our data set or not. So what we do is we find the interquartile range. That's the Q1 minus 1.5 times the IQR. So our interquartile range is going to be 33, our Q3, minus 19. 33 minus 19, let's do that now. That gives us 14. So we take 14 times the 1.5. That gives us 21. So now what we do is we add 21 to our quartile 3 and we subtract it from our Q1. So 19 minus 21 gives me a negative 2. And 33 plus 21 gives me 54. So now we take a look at those numbers that we got. Any number that is beyond those numbers, or any number that is less than negative 2 or bigger than 54 is going to be an outlier. And so our smallest number is 0. So that's going to be our lower bound. And our biggest number is 54, but because that's the same as the upper range, it's fine. It's not an outlier. So now we have our number line made down here. Now we're going to graph these. Our lower bound is down here at 0. Make a circle there. Our Q1 is 19. That's about right there. Let me just make this a little bigger. There we go. Our median is 21.5. Our Q3 is at 33. And our upper bound is all the way up at 54. So now when we draw those lines, line all the way across, box in the middle, the line through the box, the median. And there we have our box and whisker plot. So sometimes adding one number can change the results. So I added an 8 to this to the previous example. So now we've got a new number, so we need to find the median again. Really, it should just switch the median over 1. As we do this, start thinking about what it's going to be. Okay, our median is 21. M equals 21. Now let's find our quartiles. Alright, this one's going to be the average of 18 and 19 for our Q1. So it's going to be 18.5. Do the same thing up here. Going to be the average of 29 and 33, which is going to be 31. So our Q3 is at 31. And now we need to find that interquartile range. That's that Q3 minus Q1. So 31 minus 18.5. IQR is 12.5. So now what we do is we take 12.5 times 1.5. We get 18.75. We add and subtract it. So we go Q1 minus that, and we get a negative 0.25. So don't have to worry about any of those numbers. We go 31 plus 18.75, and we get 49.75. So that means that any number bigger than 49.75 would be an outlier. So this 54 is an outlier, which changes our box and whisker plot. So now when we graph all these points, okay, our minimum is at 0, right? Our minimum is down here at 0, and then our quartile 1 is at 18.5, our median's at 21, our Q3 is at 31, and so now our maximum would have been 54, but because 54 is an outlier, we just put a dot there, and we don't connect that one to the rest of them. 45 now is our new maximum there. So then we draw these lines. We just use these 5 numbers that are not outliers. We draw a box between these middle 3 and our line. And so that 5th number out here, which was that 6th number out here, this is an outlier. So what it means is that if we use that to calculate, it would skew our data too far away from the rest of them. And so we put a dot there, but we don't connect it to the rest of the box and whisker plot. All right. So up here I have 2 box and whisker plots, and so let's just compare these quickly. If we look, we're going to call the first one number 1 and the second one number 2. If we look at number 1, if we look at the range of number 1, it looks to be just slightly smaller than the range of the second one, and the median is a little bit more. We see that the median would connect down to there, and it's more densely related. Like the box is smaller, so the data is much closer to the median in the middle right there. If we look at our second set of data, it's got a wider spread. See that spread all the way across there? It's got a bigger box, which means its data is a little bit more spread out, not so densely located around that median. And it's even skewed more, the top one is skewed more to the right, whereas this one's more evenly spread out across all the values. Alright, that was box and whisker plots and outliers. So at your summary questions, the essential outcome is that you will be able to create a box plot using a graphing that you'll be able to create a box plot and identify outliers. Think about how do you find outliers, how are outliers represented on a box plot, and that's all.